Hey friends, welcome back. In this tutorial, we will check how we can install Karpenter on an existing EKS cluster. So let's go to the EKS service and review our cluster. So I have already created a cluster called the demo cluster, and in that one I have a node group, and in that node group I have one T3 medium instance already running. So in order to install Karpenter, Karpenter has provided a good documentation. So let's go to that one. On the getting started with the Karpenter, this is actually the documentation for installing a new EKS cluster, creating a new EKS cluster and installing Karpenter on that one. But unfortunately, this is not good documentation for installing Karpenter on an existing EKS cluster. So what we can do is we can follow the migrating from cluster autoscaler. Even though we don't have a cluster autoscaler in our EKS, we can follow this documentation and install Karpenter on that and on the EKS cluster. So let's set the some of the environment variable first. So first is Karpenter namespace and second is a cluster name. So in order to update the details or install the Karpenter, I have an EC2 instance. I am using that as a jump server to connect to the EKS cluster. So on that gem server, I have already installed AWS CLI and kubectl. So let's check whether I have access to the to the EKS cluster. So let's see then whether I can see the nodes. Great. So I can see the node. So that means I have access to the Kubernetes cluster. So let's set up the environment variable first. Change the name to your cluster name. In my case, the cluster name is demo cluster, and then set the environment variable for AWS partition, AWS region, OIDC endpoint, and AWS account ID. Let's copy and run it. So that is completed. And then the IAM role. So we need to create two roles. One is for the Karpenter node role, and second is the Karpenter controller role. So let's create the first role, Karpenter node role. So this is basically it's creating a trust relationship. The trust relationship is for the EC2 EC2 service. So let's go ahead and create this. Okay, now attach the policies. So here in this case, we have to attach Amazon EKS worker node policy, CNI policy, and the container registry read-only policy, and SSM managed instance code. So if you remember, when we are installing EKS and when we are adding the node group, we have to have a role associated with that, right? For that role, we will be having all these three policies assigned to that role. Only additional policy which we are adding is Amazon SSM managed instance core. Okay, let's add these policies to the role. Okay, that is being created. Now let's copy the second one, and here in this case, this trust relationship is actually into the OIDC endpoint. Okay, through OIDC endpoint only it is creating that node groups, or also basically the nodes. So let's copy this and run it. Okay, go to the IAM and see whether these roles are created. So we can see that there are two roles which are created, and now follow the documentation and tag the subnets and security group. For that, just copy this and then run it. Okay, so the tagging is done. Here there is one step we need to remember. So there is a launch template. It's adding tagging a security group. There are two levels the security group can be added. One is at the cluster level and another is at the launch template level. So if you are following, if you are using the security group from the launch template, then you need to run this command instead of this one. And if you are using the security group from the cluster level, then you need to run this one. So I am using security group from the cluster level, so I am running the, the top command. So let's come here and run this. Okay, so that's one. And one more command we need to run, that is easy to create. Copy and run it. Okay, that is also done. Now we need to update auth config map in order to provide permission for Karpenter to create the nodes. So edit the auth config, copy the details. So we need to change some of the details here. So let's come here. So we need to make sure the indentation is correct. On the role ARN, we need to change the AWS partition to AWS and account ID. Copy your account ID. So come here, copy that and paste it here, and then the cluster name. In my case, it is demo cluster. Okay, so apply the changes. So config map is edited. So that means now Karpenter will have permission to create the nodes. So now let's install the Karpenter. So paste the version, then run the helm command. Okay, so this created a carpenter.yaml file. So we carpenter.yaml file. So we need to update some details on the YAML file. So basically on the node affinity, you need to copy this match expression section, identify the node affinity section and update this match expression. So for the node group name, let's go to the cluster and come to the compute instance and come to the node group, copy the node group name and change the node group parameter with the node group name value. Paste it. And now save the document. Then we need to apply this. So for that, run this command. So that is done. Now create the node pool. So for node pool, we need to update some of the details. So just copy the YAML file. We will create a YAML file here. Paste the details. Then edit the cluster name. So I am changing the capacity type from sport to on demand because sport require another IAM role just to make it quick. I'm just updating this to on demand. Okay, that's it. Now apply this. Okay, so both are created. Let's review whether the Karpenter pod is created under cube system namespace. Okay, it is created. Why? Because only one is showing us running is because I have only one node and it is a small instance. That's why if I add one more node, this will definitely comes as running. But in my case, it's a demo instance, so I just need only one pod running. So in order to confirm the Carpenter is working fine, we will now deploy an application into this cluster and see whether the Carpenter is taking action and creating a new node and deploying the application into the nodes. Let's log into the EC2 instance in a different window so that we can review the log as well. So this be there. Let's take Carpenter running Carpenter port name ZTL logs minus cube system. Okay, so it is running on the other. Let's create a deployment. ZTL create deployment. I'm running an Nginx application, so name is Nginx. Image is also Nginx, and replicas giving 15 instance. Okay, let's review the status. Okay, it is on the pending status, and let's see what is happening here. Okay, so the Carpenter identified the new application, the port creation request. Okay, and it is comparing multiple instances, C3 large, C3x large, and C4 large, and finally it will identify one instance. So in this case, it is identified C7a medium instance to as a node that can be used to run this particular applications. So it is initialize the node creation that will have an IP address of 10.0 to 139. So let's come to our node group and see whether that, okay, sure, that is created. It is a C7a medium 10.0 to 139 itself. And let's see whether the nodes are created. The node are created and the pod is also created. So let's review get node. So you can see the node as well here. This is how we can scale the node. Now let's see how we can how the Carpenter will respond to the scaling event. So let's delete the deployment ctl or update the replica count to 0. Okay, so no pod available. Now let's see what will happen here. So it is identified that the new node is available to terminate, and it is terminating all the pod which is running on that particular node, and then it is going to delete that. Let's review the nodes. So it's already been deleted. So it's really fast, and it is scaling in and scaling out much faster than the cluster autoscaler. I hope this video is helpful for you. Thank you so much for watching.